Hi everyone, how's it going? Today I'm going to be showing you one of the best tutorials when it comes to using Python for data science. Now, data science is the science of using data. It is what powers things like machine learning models. It's what powers a lot of statistics in Python. And so for this tutorial, I'd highly suggest to have some level of Python, but I have a separate tutorial, and several actually, teaching you exactly how to learn the fundamentals. And using machine learning models is one of the most amazing ways that you can actually make the most of Python. In a very short amount of time, I'm going to be showing you libraries that you can use to analyze data. I'm going to be showing you how you can then plot that data, and then how to create a very simple machine learning model that is trained on that data. And we're going to be analyzing what factors lead to different prices of houses. You could start to use it to understand housing prices, what houses are undervalued, which ones are overvalued. It could even help with real estate use cases. Again, this is not financial advice, but it starts to be really interesting for financial use cases in analyzing housing data and rental data. And so let's jump straight into it. For this tutorial, we're going to, as with all my tutorials, be using Google Colab. So I want you to stop what you're doing right now, and whether you're on your phone or on your computer, I want you to go to Colab in your browser, colab.research.google.com, or you can Google Google Colab. This is like the Google Docs equivalent, but for creating code in Python. So we're going to go here and create a new notebook, and this is where we're going to write all of our data science code. So I've gone up here and I'm just going to write data science with Python. I'm going to data science and machine learning with Python. And I'm going to start off very simply. If you've looked up my other tutorials, we've done things like importing libraries. Data science can be so complex that we tend to rely on tools other people have created. And so I'm going to just start off with a comment. A comment in Python, like on Twitter, starts with a hashtag. And we write import pandas. And pandas is one of the main tools that we're going to be using in order to do advanced data science things. Essentially, it helps you create a data frame, a table. It's much like an Excel spreadsheet, but in Python. And it's going to allow us to much more easily work with data that sits in a table. So as you see here, the autocomplete is already suggesting it, but you write import pandas as PD. And to show you just a quick example of what this looks like, in Python, you can actually create table data that you can interact with in an interesting way. So I'm going to write here, for example, a variable called subscribers. And I do subscribers equals, and we create a list with square brackets. We create another list, and I'm going to write the first row. And I say Kiki, which is my channel, has 1 million subscribers. So here, hopefully in the future this happens. Next, we have Mr. Beast. And let's say that they have 100,000 subscribers. Obviously not true, but... and then we have another square brackets, and we write Messi. And they have 10 million subscribers. So 1, 2, 3, 1, 2, 3. I think that's 10 million. And so what we've done here is we've created a list of lists that is possible in Python. But if you think about it, it's as if this was the first row of a table, this is the second row, and this is the third row. And I'll be showing you in a second what that's like. So in pandas, up here, we can create a data frame. And so we do that by doing a new variable, and we can call it new data frame. And we do PD dot, make sure to put the capital here, capital D data frame and capital F. And then we do data equals subscribers. So basically I'm saying, hey, I have this data. I want you to make it into a nice table. And the data I want you to pull from is subscribers. And here I then want to write what the columns are, right? I haven't even said what these columns are. It knows there's a first value, a second value, and all these stuff. But what are the names of the columns? So we write columns equals square brackets, name, comma, subscribers. So there we go. It's that easy. And now we can print new data frame in order to print this out. And there you go. It's printed out name, subscribers, and it has this nice table feel to it. So as I explained, this first row is the first row here, this second one is the second row here, and this third one is the third row here. So that's pretty much it in terms of how you can set up a Pandas data frame. Whenever you think of Pandas data frame, think of like a table or an Excel spreadsheet, but in Python. Cool. Now we're going to be importing a lot more libraries. Data science can be quite complicated, and to be honest, you'll think of machine learning and data science and think it's so complicated. In reality, there's really smart people that have already created all this stuff. And so we just use the amazing tools that they've created. And this is what people do in production and what I do all the time. So we're going to start by importing pandas as PD. This is what we did before. Next, we're going to import NumPy as NP. NumPy is very similar to pandas. It allows us to basically do interesting stuff with data and tables. Next, we're going to import a graphing library called matplotlib. Yes, it is quite a complicated name, but you write matplotlib dot pyplot as PLT. And so when we use PLT, it will import this plotting and graphing library so we can do nice visualizations. And lastly, we're going to import from sklearn.datasets, import fetch California housing, and this is our data set for California housing, as it says. And then from sklearn is the library that has a lot of machine learning tools, and I highly recommend it. So you can write from sklearn_model, import linear regression. This is one of the simplest machine learning models, but from data, it plots a line of best fit. From primary and secondary school, you probably remember those lines of best fit that given data, it predicts the best kind of general path. That is the model that we're going to be using today. And then we do %, matplotlib inline. And this will help us plot things inline here. So I've run this and it's running fine. I don't expect anything else. I've just imported things. Next, we get into the fun part of loading data. Typically, a lot of data science is actually a lot of data pre-processing, because how good your AI and models and machine learning is depends on the quality of your data. So we're going to start off by writing data equals fetch California housing. And then we do these brackets like this. So that's how we import it. Next, we do housing _df. Make sure you write this right. But, we can write housing data. And we can make it into a data frame. So we do pd.dataframe, like we did before, data.data, and then we do comma. And for the columns, the data we're importing already has the column specified. And so as you've seen here in the completion, we write data.feature names. And so you might be wondering what these feature names are. I'm just going to print the feature names here so you can see what it's like. Data.feature names. If I run this, you can see these are all of the columns within this table that we loaded. I'll show you in a second. But basically, this housing data comes with the median income of that house, the average age of that house, the average rooms, average bedrooms, population, occupancy. These are the columns of this data set that we've imported. And if I print, for example, instead here, housing data.head, you can see here the first 4 rows of this data set in Pandas. So the last thing I'm going to write here is housing data. I'll copy this and I'll write medium square brackets and make sure to have this exactly the way I'm writing it. Med house val, which is a field that's contained, equals data.target. These values are all columns that influence the housing price. And here is the actual housing price that we're setting, and it's located a little bit differently. So that's what we're just setting. I'm just going to now print a bunch of things here so you can make sure that you understand exactly what's going on behind the hood. But we take this housing data and we print basically the first 5 rows. And so we do that by housing data.head. It prints out the header, the first 5 rows of the values. I'm also going to print the data.feature names so that you know the values here. And lastly, I'm going to print here the, what if I want to get the first row? The way that I do that is I do data.data. What if I want to print the first row? The way I do that is I write print housing data dot ILOC or iloc, and I can do 0. And what that does is it'll print the first column. So here, if I look at the print statements, I've printed the first 5 rows here, which I can get here. I've printed the columns, and here are all of the column names right here. And then I've printed the first row. And this first row here, which I see 8.3252, is printed here. And this is all of the first row of values that I have here. So cool. That's how you access and load the data from Pandas. And next, what we're going to get onto is actually creating a correlation. And we're going to start to plot this. And what a correlation is saying, okay, we have all of these things that may influence the value and the price of a house, right? Ultimately, we want to see, okay, how can we maximize the price of this house generally? And these are some variables that influence that. So the median income of the family, of whoever's buying, the average age of the house, the average rooms, the average bedrooms, the average occupancy, the latitude and longitude. So these are all values that could influence the price of the house. And so we can write, for example, here, correlation. We want to see how correlated these are. There might be some things that are completely correlated and influence the value of the house, like the amount of rooms. There might be things that don't influence it at all, such as whether the grass is long or short, right? So we write correlation equals housing data underscore data. So that was the variable that we have up there. And then we write .corr, so .core. And then what we want to do after is square brackets. And we want to write med house val like this, make sure it's exactly like this. And then do .drop med house val, because we don't want that to be included. We're looking for the variables that correlate to this. We're not looking for that variable itself. So that is the correlation. And now I'll show you how you can plot it. You write plt.figure. Then you write, is it's auto-completing here, fig size all together equals brackets. And now I'm going to write here 20, 6. This is going to be the size of the plot that we're about to do. It's going to be 20 by 6. Then we write plt.bar. This is how you do a bar chart. And we write correlation, which we have up here. I'll paste it into here. Dot index, comma, correlation, dot values. And the last thing I have to do is, now it's created this plot, it's created the bar charts for the correlation, but now I actually have to show it, and I do plt.show. So if I run this, here I'll get actually the correlation, and it's pretty cool. So here it shows that it's correlated up to a 0.6 for the median income is correlated to the house price. Here, for every single change in house age, it's correlated by 0.2. Here, the average rooms is positively correlated. The more rooms, the higher the price. The average bedroom, here we see slightly negatively correlated, but it might be so small that it could be just a blip in the data or a outlier. Here, same with population. These are very smallly correlated, so it's hard to tell. The latitude and the longitude, so the latitude is negatively correlated and the longitude is a little bit less. Now, this is obviously a bit of a generalization. You'll see that the more specific and general the data sets you get, these variables will start to change. And what I'd highly recommend is actually looking deeper into this data. But let's, for the time being, assume that this is completely correct. It starts to draw some pretty interesting patterns where you can see how a single change in these variables affects the housing price. So now that we've done the correlation, we want to start to build a ML model. So a very simple machine learning model. I'm going to write here, build a simple ML machine learning model. And what I write is X in capital. This is our X variables, as you see here. These are our variables that we've written here. And we write housing underscore data is, and then we put square brackets data.feature names. So these are those columns. So we're going to take all of those columns. And then for Y, which is the variable that we're predicting for, we do housing data, and is written here, med house val, which is the median house value, which is the expected price of that house. So to make a model, a machine learning model, a very simple one, it's as easy as writing model equals linear regression, and then model.fit X and Y. So that's what we do here. We can put this run, make this run, and here we have the machine learning model that has been trained on this data set to perform. So that's how you build a very simple ML model. I'll now show you what it looks like when we plot it. And so if I go here, and if I write plot ML model predictions, what I'm going to do now is I'm going to pass a lot of data through the model and show how it changes when the model predicts the data versus the actual values. Realistically, I'll show you in another course that you shouldn't mix up the data. What we've done here is we've trained the model on this big source of data, but because this model has seen this data before, it's kind of biased. It has an unfair advantage because it's been trained on this data, and now we're going to ask it to predict this data, but it's seen this data before. And so realistically, you want to have a separate type of data called a test set, which the model hasn't seen before, and you give it to it. But for simplicity, I'm just going to show you here how you can plot something very simple. So here you do plt.figure. And so this is, as we did before, this is how you create a canvas like this. And we're going to do the same thing, which we did before, which is fig size equals 20,6. Then next, we're going to write plt.scatter. So we're going to do all of these different scatter dots. And for that, what we write is housing underscore data, med house val. Then we do comma housing data, and we're going to pick one value here to see how it correlates. Okay, so we'll do housing data med. Let's actually do house age. House age, and then we're gonna add a label, and we're gonna say label is, this is the actual data. So label is actual. Next, we're gonna copy paste this line, so exactly the same thing, but instead of the real values, we wanna write the predicted values. And so what we're gonna have to do is we're going to write above this, instead of, well, actually, I'll just show you this. We'll plot this, and we do plt.show. And before that, we write one more line, which is plt.xLabel, and we write house value, house age, and then we copy paste this, and for y label we do house age. So we make this run here, and as you can see here, this is the house age and the house value, which is pretty scattered, to be honest. So we see that there's not maybe a very strong correlation here, as you can see, between both. But if I, instead of house age, do med inc, which is medium income, and I run it again, you can see that this starts to be very correlated, which is what we've written here as well. So it starts to have a very strong correlation with the medium income of that household. So now we want to plot, this is just the real data. What about the machine learning model? What is it predicting? So what we can write here is housing data underscore data predict, and then we do square brackets predicted. So these are the predictions of the machine learning model, and we do model.predict x. So we give it all of the data that we've plotted here, and we say, hey, without looking at the answer, but it's already been trained on it, so it kind of knows, given all of these values that we give you here for each specific house, predict the price of that house. So we do housing data predicted model.predict. And we're going to write here a couple of other things that will help us, such as housing. So we'll write the predicted there. And what we now do is we copy paste the scatter line. We'll put a new scatter here. And instead of here, the housing median value, what we're going to do is we're copy pasting this housing data predicted. So that's it. That's all you have to write. And if we run this, you'll now see two types of data where we have the housing value and we have the predicted values. And I can't see which is which now. So I'm going to do a new line called plot plt.legend like this, and it will tell me which one is which. So here it says the blue is the actual values and the orange is the ones that it would predict. And we see here that the model is doing pretty good, right? It's predicting roughly very similar to what the actual correlation is, right? With the median income increasing, this is how it changes. But note that it's not usually going to be the same, because there's other values apart from the median income, like the average rooms, age, bedrooms, population, that impact the trajectory or the prediction or the model. And so this model is predicting based on a lot of other things. And so that's why we might not expect a full correlation. But if here, for example, I plot a line of best fit, which I can do if I do, I write here COE, so COEF act equals NP dot polyfit, and then I copy paste this housing data median value. So I put this into the polyfit, I'll correct that because I did a typo. And then I do comma. I copy this med ink piece here, and then I do comma 1. Then in the next line, I do x underscore act, which is the actual values, and I do np.lin space. And then what you want to do is you want to copy paste the housing value here. Then you do .min, and so this lets it know that this is the minimum value. And then you want to do the same thing. You can copy paste this exact thing, but instead of min, you write max here, and this defines the limits. So lastly here, I do plt.plot. I then do x underscore act, which is this piece. I do comma, and I do np.polyval, and then I insert the coef act, so the actual coefficient here. I do comma and x act here, and then that is pretty much it, but I just do comma and I do quotes r minus minus or dash dash, and this is going to be the line. So now if I let this run, as you've seen, it creates a, oh, actually I have to write here, I've written both as actual. This is not good. So I have to write this as predicted. If I now run this, I can see here that it's plotted here the line of best fit for the housing data and the predicted. And here you see the housing data ideally follows this line. And so this model ideally would follow this line, but it's influenced by so many other variables that it's taking into account apart from medium income that it's plotting on this line. And so this model you can think of as what you would expect. Obviously it has some error, but when you have a housing price, this is what you should expect. But this is what the actual is being at the moment. And so here I can easily change this line of best fit to show you what the model is doing by, instead of writing medium house value here, I can write predicted. So I do predicted here, and predicted here. And if I run this, here I'm getting the line of best fit, but for the model. So the predicted values that the model did. So that is pretty much it of how you can do the correlation. You can see how correlated different values are. You can create and train a model and then plot it on a chart. You can see how it differs from some of the actual data. You can also then start to change some of these medium income values and start to see, okay, if I change this to house age, how does this start to change? So I change all of the instances of this here. And if I plot it here, which I've just run the values, you can see here that this data is much more sparse. So it's drawn a line, but as you can see here, it doesn't seem like there's as strong of a pattern. So I'd prompt you to actually try to change some of these ones and see how it goes. And if you want to actually run the machine learning model on specific values, you can actually see it here. So for example, if I go here and I write something like prediction equals model.predict, I can give it the values up here of medium income, house age, average rooms, all this stuff. And so I can say, okay, I'm looking at a new house, and if I have 4.5 is the medium income, I think it's in hundreds of thousands here, for example, and I have 30, I believe it was for the rooms, 5, 1,500, 3, 37, and minus 120. So this is the latitude and the longitude, but I would just look at these variable names and look at what you want it to be. And then I do square bracket 0. And if I lastly do print prediction, and then plus Then you do str to convert it into a string so we can print it. And then we paste it here. There is one thing missing here, I believe. Prediction. Let's see, expected 2D array. I think I need one more pair of square brackets, yes. So I put one more square brackets here and I run it. Here we go, it says the prediction is 1.9. And so note that this housing value, I believe, is in hundreds of thousands of dollars. But here it's saying for a medium income of 4.5, I think it's hundreds of thousands of dollars, this amount of house age, average rooms, etc. This is what I would expect the price of that house to be. Note that this model prediction isn't perfect, but it starts to be really cool. Because if you expand this further and you look at actually the amount of error there is, etc., you can start to try this with real houses and see how it compares to your model's prediction. Note this isn't financial advice. Note that there is a lot of error when it comes to machine learning models. But if you found this interesting, please give a like, drop a comment of what you'd like to see next. And what if you wanted to extend this project, what I would do if I were you was I would try out to see the different variables here. I would then also break this up so that you're not training on all of the data here that we've been given, but you take out 80% of the data for training, and the last 20% is what you use to draw this graph and see how it actually performs. And what I'd also prompt you to do is search up online how to draw error bars, because this prediction and this thing that we've done here will have some level of error, and you want to know what that error is. So hope you found this useful. Please let me know what you'd like to see next, and have a good rest of the day.